for your information.
Okay.
Okay.
So we're right now in the repository that we have available. We can see the log for this repository. We have the tags for these assignments 1, 2, and 3. Well, 1-1, 1-2, and 1-3. Great, right now, so we're gonna go to the first assignment. I think, how is it run? I don't remember. Go test, run. Is it?
I think it's just go test for that one.
Okay. Oh, sorry. Yep. Okay, so we run the first the first test, the first part. We're gonna see the code like real fast. Assignment 1, Q1. So the objective of this was to create this function. I don't know if Roberto, you can help me out with this to explain the really quickly the function of this.
Yep. For me, it was kind of great. Let me know if my microphone is.
Yes, we can hear you.
Okay. So to me, when I saw Q1 and Q2, it seems like it was like a ramp up for the real project, which was a map reduce, and it seems like Q1 was just a let's say count of words in some input file, and then the objective was to find the top or the top most repeated words in that file. So what I did is basically just start with the reading the input file, and then the instructions were very clear in terms of we need to consider everything to be as a lowercase, and we need to strip all the non-alphanumeric characters out of the string, and then we thought that we just need to split it into words, and there was a hint about using fields from strings, so we used that, and then we just started counting words. And what it was really useful is that there was already a function provided that we're sorting the words, so we just use it, and then we two things that are very important are part of the parameters are the threshold, the character threshold for a word to be considered a word or to be considered into the counting. So that is basically just saying, what would be the length for a word to be considered a part of the counting, and then the other one is how many words or the number of words that we would like to present as a top K, most repeated words in that input file. So that's kind of what we did, and I think that's it for Q1. Yeah.
Yeah, we can go to the Q2. We're gonna do the same with the export. And here we have the two folders, the main folder and the map reduce folder. I believe this one is go test -run. I don't remember the exact command. Map reduce probably. Let me see what's going on over there. Okay, probably test. Oh yeah, this one.
For assignment 1-2, there it was the sequential map reduce. So you need to test it like go test, then the dash run sequential. You just
Okay.
sequential with capital S. Yeah.
Yep. So right now this is running. It's gonna take a while since my computer is not that good and I'm running Zoom at the same time, but we can see that it is running okay.
Okay.
And we're gonna go through the code in a little bit. Assignment 2. So the thing was to implement these functions about the map and the reduce function. I didn't delete these comments. We included some other comments. The objective was to include this do map and the other function in the reduce. So basically what we are going to be doing here is the objective for this was to from files we have to provide the whole sequence for the map reduce. So what we're going here is we have an input file which we're gonna be calling the map function, which at the same time the map function is gonna return the key values. The key values, the input will be the in file and also the file contents. That's why we're having this written on the file. We're gonna start right in a moment the map function, but once we have the key values, we have this slice of encoders, JSON encoders, the size of the end reduce that we have also as a parameter in the function. So we traverse from 0 to end reduce. And of course, we have the new file name to have the intermediate names for this whole map and reduce process. We have this new name and we create the file. Once we create the file, we have this instruction for declosing the file once we finish writing to this file. And we create this new encoder and we set it into this slide that we created for this size. Once you have the array, or in this case, slices, we traverse through the keys that we have from returning from the map function. We create a hash key from this key value. And with this instruction, we call the encoder. Since we have only n reduced number of encoders, this function returned a really big value, and we have with this module number operation, we make sure that the range of this operation will be in the range of the size of the encoders. That's why once we have this hash value, depending on the value, will be limited into this and reduce size of the array. We have the encoder, and we encode this result of from the map function that we're going to see at the moment. So this is the simple do reduce, the do map. Sorry, we're gonna go see the map function itself. I think it's gonna be schedule, no. Run, no.
The map function is located in main.
Main in WC, right?
Yep.
Yeah, over here. This is the map function, and the reduce function are going to be called the other way. So as we see, we have an input as the name of the document and the inputs of the document. We have to return a slice of this structure that is a map reduce key value. You can see this is a structure that has only 2 strings. One is called, I think, key, and the other one is called value. So we have the input and we traverse through, from the input, we get the information, we divide it into a slice, sorry, and we put it into words. So we traverse into this slide, and these values are put into this variable, and we just append the variable. Here's a typo, I don't know what happened there. So we just append that from the result value, these new key values, which is gonna happen is gonna, for example, if we have a word called Roberto, it's gonna have included in, well, later in the encoder, we then have this value over here, and for the value, it's gonna include this array of 1. I'm gonna have multiple of these into this file, which later we'll see in the reduce part, how they are together into from 1,1,1,1 into a single value that's gonna be, for example, 5 or 6 or 7. So this is the map function. We're gonna go see the other part, the reduce function. The reduce, we create a mapper. This is just like a single map in other languages. We have a key value, and we have an array and a slice of strings. We go through this loop for n map, the number of map executions that happen in the last process, in the last part. We create the new file name. We open the file name. Of course, we always check for the errors. Again, we also set this defer instruction to close this file that we just opened once we are finished with it. We create a new decoder in this case because we are now reading the JSON files that we have created first in the map part. We create this structure called KB for the key value, the same one that we saw in the map function. And we traverse, and this is an infinite loop, but we break it with this instruction once we reach the end of the file. And we know when we perform a decode on the function, I mean on the file itself, we decode the line and we save it into this structure. And once we have reached the end of the file, we break the for loop, the infinite while loop. If not, if there's an error, we check with this function. If there was no error, we only create in this mapper, which was like a normal map, can only have one of these values. We say in this value, we append the current value with the new value. So in this case, we have like we have several of these. For example, we have one that says Roberto 1, another one says Roberto 1. We have two different lines. When I created this into only Roberto 1,1 to say that we have two of these different scenarios where this award is received. Once this file was decoded completely, we created this new other merge name. We have this is another function that was given to us. We create this new file for the other part of the merge process of this map reduce process. Again, we call this defer function. Once we finish with this instruction, with this file, it's going to close it automatically. We create in this new encoder for us. I think was required for us to have this new encoder in the part of the merge part, and we traverse through the map that we created before. That way, once we have, in this case, for example, the key has a halo. Before it was 1,1,1, something. This one is going to be moved into a single value that in this case was 2, but it's going to be calculated with this reducer function that we're going to see in a moment. So basically what this function is going to have an array of the key and a value, and it's gonna convert it into only a value. I'm gonna go over here in the WC. The reduce function, as we see, there's a key and array of values, I mean, slice of values. We only count the number of values that we have available. I mean, of course, the V is for the value that we're receiving over here from this traversing. So this one is a string. That's why you have to convert it into an integer, to add it to the total number. And as a result, we have to return a string as well. That's why we have this casting into a string. And once we go over here, we have to encode into the file, and into the final merge file will be the key, the given key. This is any word that we have decided, and a value that's going to be the number of times the word was repeated. In this case, was 2, but it could be any other value. It could be 1 all the way to, I don't know. And at the end, this one is repeated since we created over here. But that was part of this exercise 2. For the exercise assignment number 3, go run, and I'll go test.
Sure.
Well, the first one was run.
And then this basic, yeah.
This basic and map reduce. This one is going to be the exact same situation as the assignment 1-2. The only situation that the first one was sequential, and this one is going to be done with sockets inside the computer. So it's going to be like a distributed system. So you have different threads doing the same situation. So this one, the first test, I mean, you all see it, but it's only going to create 2 workers for the map and for the reduce, process. And it's going to do it in different threads. And once it finishes, it's going to have the whole process. We can see the difference, for example. In the first part, the sequential part was 7.6 seconds. In this one, with concurrent threads, was 4.8 seconds in this case. This is like the part 1 of the assignment 1.3. See the code. I don't know how well we are in time. Basically, the do reduce, the do map and all that stuff is the same as assignment 1.2, so that we don't have to go through all of that.
It's fine. I mean, Ricardo, thank you. It's I mean, now you went through it so detailed, and it's just fine. So,
Okay.
So I'm just worried to running out of time, because also I want to ask if anyone has questions.
Okay. Yeah, I'm gonna go a little bit faster. We modified this schedule function to have this do task, do map, and do reduce part. So we have 2 inputs. This part was already included. We created in order to call for these other workers, we have to call an RPC, that is this over here, with an argument with these do task arguments. That way they can know the job name, the file, the phase part, task number, etc. So what we did was, of course, fill the structure. We pass it as an argument. This one is like a parameter to the call for the RPC. What we did here is, I think, is the more important part. We have a slice of workers in the master, and this can have different workers be joining at any moment or going out of our service, you could say, out of any moment. We're going for end tasks. So in case there's a failure, in case for, I don't know, a timeout or something, in this case was a timeout, we just reassign this task. That's why we have this reduce of 1 this iterator. We just reassign the task to another worker, and how we assure that is we have this other variable called current worker that is not going to be resetting. It's going to be always increasing in value and be limited to this model of the worker size. Worker size is the amount of workers that we have available at the moment. That way, for example, in one run, this was, for example, 0 and 0. This is going to be the worker number 0. And the next one is going to be, this is going to be increased. It's going to be 1, and current worker is also going to be increased. It's going to be the worker 3, for example. If you have 3 workers, it's going to be that one. If not, it's going to be limited to this worker size. That way, once there is an error, we're going to be assigning the same task, that is, in this case is I, but to a different worker, since this one is going to be increasing, it's going to be changing the worker. That's why you're not going to be always assigning the same task to the same worker, in this case of failures.
So to sum up, it kind of felt like fun, going from the basics like Q1, Q2, and then every step in the way it was like a step up, like going high up in the hill, and every time it was like an incremental thing. And the challenging part is that there were to map and reduce, let's say, code. The first one, the map, the do map and the do reduce, it's kind of it's actually part of the framework of the map reduce. So we were given like not complete map reduce, and we were supposed to finish the framework. The reduce function and the map function, which sounds kind of similar, but they are different. It's the actual functionality that a developer should write to use the MapReduce framework. And I think those two functions were the easier ones. The complicated ones were the do reduce, and the schedule, which are part of the MapReduce, but allow us to comprehend really well how the MapReduce framework actually works. So I mean, that's it.
Thank you, guys. It was great detailed talk about it. Anyone has questions? If your approach was different, you're wondering about something. No? Okay, perfect. Thank you, Ricardo, Roberto. Thank you, Group 1, for the detailed presentation. Let's go to Group 2.
Hello.
Hi.
Okay.
Go on. So we're just going to start.
Okay. Yeah. I'm going to start. Well, first, hello, class. I'm going to start with the assignment 1.1, which is the easiest part of all this project. We have just to write 2 files, Q1 and Q2. The first one, it's to count the most of keywords in the document. I think for all of us, the approach will be the same. I'm not going to explain the code because I think it doesn't make sense. I'm just going to provide a var view. So what we do here is read a file, read each word with the regex that the code provides. And we just need to validate that each word meets the requirements for the chart threshold. And we just need to count, and that's it. There are no more complications. And for Q2, we just need to make a sum. We were provided with a list of number. In this case, we are required to use the keyword go for subroutines, and we need to run the sum worker subroutine to make the calculations of the numbers in let's say in a parallel way, just to we can do this in a for loop. We can just sum each number, but the purpose of this is use the walk keyword to know, to get familiarized with the with the subroutines and the channels. And for Q2, we just need to iterate over a list of numbers, make the sum, and put the sum in channels. And for Q2, that's it.
Do you want to run the test?
Mm-hmm.
Are you gonna run them? Sorry, or
No.
You're not going to run it?
I can run.
Okay, yeah, please.
Okay.
Right. Okay, here we are in assignment 1. Let's go. Okay, here it is. The first part. But I think this is a test for the 1-1.
Okay, that's pretty fast.
Okay. Next part is 1.2. I think Antonio is going to explain this.
Yes. Let me share my screen. So yeah. Can you see Visual Studio? That's right.
Yes.
So I'm gonna do like, oh, okay. It's this one, sorry. Well, beginning by checking what files are generated. Oh, this is a mess. Well, it only counts from 0 to 4, I think. But the main thing about this is that we are going to jump into the command map. We're going to do the mapping. So we're going to read the files right now. Firstly, it's going to begin with the one with the 0, and it's going to be loaded in contents. So then, well, here in test, I run the one with 5. Yeah, with 3. I'm sorry, with 3 and reduce numbers. So we want to create them. We have a 4 here to create like 3 different of them, and we just created this other 3 files, right? So now we're going to send these contents that we just loaded into the mapf function. Well, I didn't put any test point there, but going to this function, we can see that we're going to return a variable which is a go slice type of key values of the key value struct, and we're going to basically this function is going to split the value here, which is the contents that we just sent. It's going to split them, and it's going to append them by taking into account the worth, and it's going to stack some ones. So some characters into that value. Then going back, so we have well, the first character is a 0. We're basically using the iHash function to have like a random index generator, which is going to be from 0 to 2. And this is going to select into which into which JSON it's going to store the value. Okay, so yeah, basically it's switching the index and it's going to write it into this encoder. And well, this is going to iterate here the whole file, and then we're going to close all of the files that we just opened, we just used. Then we're going to, well, this is going to run 3 times or 5 times. And then we jump to reduce. So we just generated these files from the map file, common map. And we're going to also use the we're also going to load the files. So we have here like five indices. We're going to load 5 of them. And here we are going to read those files. So we are now currently going for the one with a 0 index. So we're creating our encoder, and in this part, we're creating a new struct of key value. And here we're just going to decode it, and if it gives us an error, it's probably meant that the file is done. I mean, it just read through all of it. But yeah, we're going to basically store the things in cached KV. And then we are going to iterate over 5 times over this for loop. And then we're going to jump into the, well, this part is only converting a map type to a ghost slice. I mean. And then we end up with this, which isn't arranged. It's kind of a mess, but then we just sort those keys. Then we're going to create the file to store the results. We check for some errors. We defer file close until the end of the function. We're creating a new encoder file. And here we go to the reduce F to write the result. So here it's like very simple. We're just grabbing the values and assigning them to a single value once at a time, and we're converting them to ASCII. And if it doesn't give us an error, it's going to just stack them up. It's going to sum them until it's done with the values, and it's going to return it them in an integer type. And then, well, that's basically it. So it's going to reduce all of them. It's going to, okay. So that's it with the 1-2. If you
Can
want
you
to continue, Marco.
run the test in a way that we can see the time?
You want to check the time. Oh, yeah.
Okay.
Yeah, so this is all trash. But yeah, if you want to continue, Marco.
Yeah. Okay, the 1.3 was to now the closest approach to a distributed work. In the well, the idea is to initialize workers. I think that is done in master, if I remember, or in the tests example. Here the test is starting workers. This one here starting 2 workers, and well, our job was to distribute tasks into the workers that are active. So our first step is to wait a worker to be ready. We are doing this using the register channel, which is a channel that sends a signal when a worker is registered. So when we receive something here, we have at least 1 worker. So here we start the distribution of tasks. Iterate from 0 to the number of tasks. We build a structure that the RPC requires to know what that worker is going to do. Here we indicate the master job name, the file that is going to use, the phase in which it is, the number of tasks, and the rest of the number of other tasks that have to be processed. Here we are, a different way that to restart the index of the worker. We start in 0, as you can see here. But this line, what it does is if we exceed the number of workers, we are resetting the index of the worker. So we are not going out of the bounds of the worker. Okay, so here we call the task. We send, as you see, the task arguments. We ask to run the do task procedure, the mode procedure, and we indicate, the worker that is going to execute that. This part is for the failures. If the call is not successful, we are reducing the task number, so we have to process it again. And every time a task is completed, we are changing the index of the worker that is going to take the next task. So this way is how it is working the distribution. Let me run the test. Go test run to basic. Okay. I don't know if it was expected to show the time. Well, there is another part of the 1.3 assignment that is to implement inverted index function. Well, we have the same thing to separate it into a mapper and a reducer function. Here in the map function, the inputs are the name of the document and the content of the document. So here we split the content into words. We build a map of the words, and for each word we are assigning the name of the document, and we are building a map of words and the document that they belong to. And after the map is ready, we are building a slice of them. We iterate over all the keys of the map, and we build a slice with key value structures indicating the key that is the word, and the value is the name of the document. At the end, it returns a slice of all of these key value structures. The reducer function receives those those keys and iterates over the values that are assigned to a key. Here we are taking the length, how many values do we have? Well, for the objective of the test, here we are initializing a string with the length of the files that have that key. And after that, we are iterating all over the values that are all the documents that have that key. And we are only appending into the string, comma separated, and at the end, well, returning the final string that is built with the key and with the word and all the documents that they have that word. Let me check the other tests. Oh, here it is. It's run failure. Oh, I missed this. Well, I'm not sure if this is.
Sorry to interrupt. There is a command to clean up the cache. So we can in real time. I can.
Do you remember it, Oscar?
Yeah, I have it right here. I cannot paste it into the chat, but I can.
Yeah, just let's check if the chat is open for everyone. Now you can send it to everyone. Okay.
Copy paste. Okay. Actually, no, I can. Everyone.
Okay.
Okay, just get you. Okay, thank you.
So it would be nice if you can run both last.
Yeah. Yeah.
So let's just.
It was full display. Let me see. Yeah. Okay.
Okay.
Next one. Another failure. Okay, let's take a look more.
Okay.
There is another one. I don't know. Oh, no, not. Oh. This is to run the SH for the inverted index part. Okay. Well, this test, I think it compares the result of the inverted index with the file that is around here. Yeah, that's it. Yeah, okay. I think that's all.
Perfect. Thank you. Thank you,
Thanks.
group 2. Any questions from you guys? Oh, no one has question. Interesting. Okay. Okay. Thank you. Let's go to the third one. Group 3. How many?
Yes. Just
4, 5, 6, 4. 4
Excuse
active members. I mean, you are okay. Go ahead. Go ahead. I mean, you have 4 active.
No. Remember that Sergey, I don't remember the name of the other guy left the class.
Mm-hmm.
If you see the group, it says are 6 members, but
Yeah. I remember. Okay. Okay.
Maddie,
Yes.
I have a. Do we need to also rank our group?
Mm-hmm. Oh no, if in the rank you see there is no self-ranking, right?
There's no what?
Yeah, rank your own group too. I thought I put like 1 number less, but you can rank your own group too. You can give yourself group 1.
Okay. Okay.
Okay, group
okay,
3.
let me know when you can see my screen.
Yeah, we can see your screen. Just please like try to stick with like 12, 13 minutes, okay? So it can like, extend it to 15 minutes. So you don't need to really talk that much detail on the code. Just talk like in a big picture.
Okay, line per line. Okay, just kidding. Okay, well, like explanation about this, about the exercise 1.1, that is key 1 and key 2. As we know, what? Okay, the exercise is trying to find the number of words that are trying to count the words that are in the files, in the input files. What is this? First, the first problematic that we saw here is that all of members of the team, we don't know well. At this point, we didn't know nothing about Go, and trying to understand. Okay, first what need to do at the beginning. Well, trying to read the file, and after different for other language like Python, you need to say when the file is showing a error, you need to specify that. And after, if you know that you want to count the words that are in the file, you need to convert all the words to lower case and avoid or omit the special characters, and if is using apostrophes or something like that. After that, well, you need to split all the words that is in the file, and after that, trying to initial the map, sorry, and split or trying to count, sorry, all the array in the data split. And in the second exercise also, you need to, okay, now you have all the words of the files. You know how words are in the file. And after that, you need to, well, in this exercise, you need to okay, you need to use different files at the same time. What it means? Okay, for this you need to create chains. What is that? Okay, the chains is a mechanism of communication that is able to create a go routine and send different values to a different go routine. This is the reason why we are using chains. That is the goals in this. When a chain is created, it is indicating the data to keep or the data that is using. In this case, we are using from our input file, we are using 2 different chains. That is for 2 different chains for input and 2 different chains for output. After that, here we are sending and receiving data from the chain. As you can see here, for example, the position of the data on the file, and you are separating that in this file. After that, you need, okay, keep in mind that if you are using channels, you need to close the channel, because after that you need to use it. It is giving an issue. It is something that you need to do. And also at the end, you need to recover the data. And here we are counting the words that are in the file. The words that are repeated. Okay, after that, we need to corroborate that the exercise is running as expected. Go test. And as you can see here, it is passing. And I don't know if someone has any question here.
I do have a question. What's the reason to use 2 channels for input and 2 channels for output?
Okay, well, in this case, the exercise is saying, okay, you need to use you need to parallelize the words that you are using. You need to have different process at the same time. For this reason, you need to create like 2 different strings, something like that, trying to use, okay, all of your file, instead of have one only string, you need to separate, and also at the same time, counting the words on the different channels. And if you are using, for example, if you have 2 different strings at the beginning, you need to have the same at the end. And okay, let me go through the code. For example, here I'm separating our numbers or our data from input. Here I'm creating 2 separate chains, but you can use 4 or 6 or the number of chains that you want to do. After, here you are counting the length. For the same reason, you need to use the same 2 strings in the like a output. But at the end, you are counting the words from the chain 0 and the chain 1 that are your 2 different chains.
Okay, cool. Thank you.
Welcome. Okay, Ale, you.
Yes, sorry.
Really?
I'm going to share my screen. Can you stop sharing, please?
Sorry. Sorry, yes.
Okay, and let me know if you can see my screen.
Yes.
Okay.
Yes.
Okay, so I'm going to, once we already know how to use map and channels, now we are going to apply it here. Well, the map, how is working the map function here. So if you If you see my screen, I'm going to, okay, so first, at the beginning, we are going to read our file that you see here, and then we are going to divide our file into objects. As you see here, if you see this, well, at the beginning, we assign here the numbers of we are going to have. In this case, we are assigned 100 values because it was like 10,000 or I don't remember, but it takes a lot of time and a lot of memory, so I reduce it. And so the first thing is that you are going to have 100 numbers. So what is the goal of the map reduce? Divide all these numbers in different tasks, in different files, and have an output with all these values sorted. So what we are doing here at the beginning, we are reading our file, and then we are going to divide it in objects. And then as it says here, we have the M reduce is the number of reduced tasks that we are going to have. If you see this file, we are going to have 5. And then we are going to, with this 4, we are going to create with this function that you see here, we are going to call for assign the name. If you see here in the common Go, you are going to see how we assign the names of each file in the input. So we are going, if you see here, we are going to divide all of our values in different files. I comment in here in the test, I comment the cleanup of this test because I comment this line because I want you to see all these files that are generated here. So the first thing, as I told you, it creates the file, and then we are going to create a new files with the key assigned to each value. So if you see here, we already have all our values with a key. This is what we are doing in our map, and then we are going to go to the reduce function, and here you are going to see that we are creating. I forgot to tell you that we encode all the files to the. Let's say that we are saying that all our files are in JSON format. So here we are going to do a new for that has the in map. If you see here, it's the number of the tasks that we are going to have for our output, and then we are going to sort all these values. If you see here, these 3 files with the rest, this one, and this one. If you see here, you already have all our values sorted. It's the 0, all the 1s, all the 2, all the 3s, and at the end, with this one, with all these sorted values, we are going to have one output file that is this one. So if you see here, we have our 0, then all the 1s or the 2, and this is what we are doing here. This is just like a test example to see how the map reduce is working, or how it functions. And then Ryan and Christian.
Could you please continue showing your screen in assignment 1-3?
Yes, sure. Okay. Let me open. I wasn't prepared for that tree.
Okay.
Can you also run the test?
Oh, yes, I forgot.
Oh, you did it already?
Here's. the number 3. Which file do you want me to share, Brian?
Well, open the ones that we modify, maybe commonmap.go, common reduce, master.go, schedule, and I.go.
Well, if you want to explain the others one, because I already explained these two, but
just Brian, try to be concise. Yeah.
Well, I don't got my computer right now. I got a trouble with it. I am a tablet, so I'm going to explain what I learned.
Okay.
Well, first we got a master file. So, well, here we call the different workers that I'm going to work. In this time we have M and R workers. M refers to a map and R to reduce, and those are the tasks we want to assign. Well, as I'll explain, we got a common map file. In common map, what we have to do is just to read some files, parse key value pairs in order to use a map function. And well, at the end of that, we get a key value pairs in different files. And well, all of this in memory, as she said, we have many files and the map function. Well, after that, we got our reduce worker or many reduce workers. Those also read the files that we generated. Well, in the paper, they call it intermediate key files. So what we have to do is to find the different, we need to find, we need to sort all the data that we got. And also we need to find all the occurrence and group all of them together. So as I said, sorting is needed because there are many different keys on the same reduced task. So we need to find them. And okay, when we set master, master calls all the master calls all the workers, and also we have a schedule file. On the schedule file, we said, okay, you need to do some we got the two cases when we are on the map, when we are doing map reduce, or when tasks or workers are doing the reduce phase. So as I explained what they do, so after that we got the data, we prepared a for loop where we said, okay, when we are doing the number of tasks that I'll explain, that there were 100. So we got different cases. A case when we are working with map phase, also the case of reduce phase, and we see what's happening during when we process that code. Ali, if you can run this to show them that it passed the test.
yes, let me, oh, sorry. No. Okay, so let me run this one.
Run the test.
Let me release. Sorry, I wasn't prepared for.
No worries.
Have a note for passwords.
It is recording, okay.
Yeah, we got our keynote.
Okay, there you go.
Christian, could you complement all the information?
Yeah, sure. Alex, can you let me share the screen and then
Yes.
go back to you? Thanks.
Sure.
Okay, so you are able to see my screen, right?
Yes.
So really quickly, I would like to mention that some of the things that help us as a team, it was going with different pages like Code Academy to review some of the exercises in the basic functions for Golang. Also, as you know, the Stack Overflow page that covers a lot of the questions that we had during the project. Also, we had to read a few times again the same document that the professor shared with us. Even some simple images like this one help us to understand what were we trying to achieve and in which phase we were dealing with across the document. And of course, the official documentation from Golang, just to understand what was this channel, the runs, and these functions that we were using for sort all these strings. And for example, in the last exercise, what we are looking for is that we have basically the temporal file that we already have explained, the count part on all these loops. But this time we're trying to understand and achieve to identify in which of these files this word is repeating or appearing. So we will keep the loop until we find in all the several books that we are reading. And after that, we will have something like this. And there the trick was to add a if clause to catch and accept in the new array or the new string that we were creating only the first occurrence of any of these. So that will give us something like this. And with the counter that we are having from here, it will be something like that. So in this way, we will be able to tell the word how many times and in which files that was showing. So we have to do this a lot. And for that, we have to, as you know, there was a debug to enable in the code. So we did that, and that make us easier. Where was it? In this one. And also we have to create our own loops, our own print messages to make it easier for us to understand, playing with some dummy data before trying to process all the books and all the instructions that we were receiving from the project. So once we were able to achieve that and identify the current phase that we were working, like the workers, the schedule, and the map and reduce that my team has already explained. So we were able to progress, and that's how we managed to modify the worker code to identify in which phase that was and why that was an issue initially. And the reason is that the time that we're running on sequence, the system takes a lot of time opening all these files, and that's not the best for the performance that we are trying to put on the code. So after that, which one is this? Yeah, let's see.
Can you run the last test?
Yeah, Alex, can you help me with that one?
Yes, let me run. Let me share my screen again. Okay. Just a moment. Okay, I'm going to share. This is the last one. It takes a while. No. Wait.
There are too many open files because.
Oh yes, because I have a lot of files here.
Yeah, the cleaner.
Yeah, you forgot to let me.
Without that issue before.
No, my computer is going to.
It's okay. It's all right. No worries.
Maybe I can present it if you
No.
want.
It's okay. It's okay. If it's if you face
Do you,
issue.
do you have the remove
Let me
files
clean it.
command? Yeah.
Okay, group 4 is ready. While we are waiting for this.
No.
Did it run before?
Yep.
Yes.
Okay.
It's because I think I have a lot of files.
Okay, so let's proceed with the group 4. Anyone has questions before?
Okay. But in our branch, it's going to pass a test.
Okay,
The
sure,
one that we push. Sorry about that.
No, no worries. I believe so. I believe that. Group, anyone has questions? No? Clear? Group 4, you ready?
Yes.
Okay, you can start sharing your screen. Anyway, Alejandra, I'm going to fade that part that you open your file. I mean, your calendar. No worries. That will be edited.
Thank you.
It happened. I have the experience once it happens in my another class. So it happens.
Yes. Can you see my screen?
Yep. Yep.
Okay. I would like to talk about more about the challenges instead of the code, because the approach of almost all the teams is very similar. And of course, in the Q1, it's to get used to the syntax of the new language, at least for me. And for example, there is no object and class concept. We are using structs instead. And it's almost the same. We are opening the file, read the content, and we're using different variables to slice the words in lowercase using to lower. After that, we're using regex to convert the words, and we are using word map, word count, a function that convert the slice into a word count. And I get a little confused in the instructions, say that we need to get not words, underservable words, and I put a list of words that there are less than my chart threshold, just for see the words that are most important. I do a few tests changing the chart threshold and the number of words, and works fine. And the last part, we are using the struct, and for the last, we are using the non-words variable to just to show the words that we are asking for. And second, Eduardo, can you help me with this one?
Yeah, sure thing. Well, the second part of the first part of this assignment was an introduction to Go functions, to Go subroutines, to Go routines. I think the most challenging part of this one, at least for people new to Go language like us, is the buffering part, because a common issue that we faced while doing this was that when we ran the test failed because of a deadlock. And the way to solve that is to make your channel buffer, right? To control the size of the buffer, we used a global variable, which is numbers per worker. This variable controls the number of numbers that every worker is going to handle. So we use that variable to control the size of the buffer for the channel as well. So I think that's it. Maybe.
Yes, for this. This is the only part 1, and this is the 1.2 and 1.3. And for this, the challenge was get used to the framework we are dealing with. We need to convert all the, first we are reading all the content of the document and using the map function, and we are getting the per Q value, and then it's almost the same in every teamwork. It's encodes the file using the file name and the file D to pass to the common and reduce phase. And this we are using a decoder to extract the key values and generating a new one to use the reduce function. And another challenge in this section of the project was to all the members of the group. We were using Windows to develop the system, and we saw that running the first test, the W05 test, well, the result is over here, and we get a file test, but the words count, it's exact the same as the result. Oh, here we go. So the problem, I think, is the text files are generating in Windows, not in Linux. To use we are using actually a bash embedded in VS Code, but the files are generated in Windows, not in a Unix system. So to validate this test, we used a virtual machine with Ubuntu and run the test again, and it works well. And almost all the tests are very similar in time to the README file. It's very similar. So this is the map and command to the schedule. Eduardo?
Oh yeah. Maybe I can elaborate a little bit more about the problem that David just described. The thing is that the test script uses a file to compare the output of the files generated by the code that we wrote. So apparently, Linux uses certain type of end of line, and Windows uses another one. So apparently, the script was detecting that as a difference between the files, even though the content was the same. I don't know, David, if you get to run the test in a successful manner.
No, just
Were you able to do that?
No, just using the terminal with Ubuntu.
Oh,
But all the rest of the test, like the last test, the II shell, it works fine.
Oh, right.
Yeah, just in using this one, in the 1.2.
Yeah, maybe just to be sure that the outputs are the same, maybe you can expand the terminal just to see that the counts are the same.
Yep.
So as you guys can see, the output are exactly the same. The counting are the same. So yeah, if you open this diff.out file, you will see that there's an end of line character at the end of every line that was generated with Windows. So that's the problem. We ran exactly the same code in a virtual machine and it worked good. So yeah, we can move on to the next one, maybe the third part of the assignment. Oh yeah, this is the code. In this part, we had to modify the schedule, and one thing that we found challenging here was that maybe maybe the instructions about the RPC wasn't very clear. We were trying to call the do task function, but we found out that no one was calling it. So who needs to call it? Ourselves, right? From the scheduler. And the way to do that is to use an RPC. So maybe that's the most complicated part of it. In the first part, we fill up the task arguments, and we call a function which is called call worker, something like that. It's if you can scroll down, please.
This part?
No, scroll down. Down.
I think that's all in this schedule.gov. It's all right, or I got the wrong?
Yeah, I think it's outdated. It's missing a function, but that's okay. Basically, that function just is using the values that we used to fill up in the args struct to pass it to the worker. Yeah. Did you run it already? The test?
Yes, it's this one.
Yeah, there it is. It's passing.
Yes, this is sequential.
So I think that's it, right?
Yes, let me run the last test.
That's it?
Yep.
Yep.
Okay, thank you guys. Any questions from anyone?
I just want to tell you that if you have problem using Windows, actually, for example, I am not using a virtual machine. When you are installing Git, you can also use Git bash. And with that Git bash, you can run there emulating like if you are in Linux.
Yeah, actually using Git bash is how we found out what the problem was. But we ended up using a virtual machine because we found it more practical, I guess. But yeah, that's a good advice.
Okay.
Yes, when you install the Git bash, the VS Code detected and actually install packages to run the terminal of your distro you are using. So that could be useful if you are a Windows guy like me.
Okay, thank you guys. Anyone has more questions, comments? Perfect. Let's continue with group 5, smallest group.
Yeah.
Yeah.
Let me share my screen. Okay. So, well, basically, as David said in the previous presentation, almost all the approaches were pretty similar. I will try to focus only on the key things about our implementation. So first of all, well, we have this first assignment, right? That it was just to count the words. One of the first challenge that we had, it's Golang was a totally new language for us. We were not familiar. Actually, something that helped us a lot was to install Atom and the Go Plus package. And that one started to catch right away all the issues and give us suggestions to all of our problems. So that one was pretty cool. And well, related to the problems that we faced. The first one was to sanitize the input, right? We have a file with several, what is the name? You know, colons and, I'm forgetting the chart names, but we need to sanitize. We spent some time trying to figure out what was the right regex. But besides that, it was pretty simple. It was just use a map as a counter to avoid duplicate duplicate values, and then just count it right away. This one was pretty simple. Another problem that we had is that because we had this, we're using this map structure, and we wanted to also use the function that the teacher is providing, we had to do some restructure of our struct. So we converted our map into a slide. So yeah, that is something else that we had to do. Besides that, pretty easy with implementation. Well, if there is there any question about this implementation or comment? Okay, I'm going to move on into the second one. The main challenge about this was figure out how to use the channels, right? So here, well, it's not only the channels because it's also that because you are using parallelism, you need to take care of waiting for all the other processes to finish and take care of, you know, don't exit out of time. So the way that we did this was we have two channels. The first one is the inputs that we are going to send into our code. I decided to have a buffer of the amount of channels that we're going to have multiplied by 3, by 3. It's a number that I liked. So yeah, we need this to avoid like processes starving, you know. It's recommended to have a few more, a buffer, a few, well, a little bigger to handle, to avoid that whenever we add a value to the channel, it is going to block the call until the buffer is again available. So we did this. And for the output, there is no science on that. You know that you have n numbers of operations that are going to do the sum. So you just at the end, you have to read all the channel again and count it right away. So in general, we have, the way that we do this is we create all the Go routines. And once that they are waiting for input, we start providing the values to the worker input. Then we close it to tell the workers that they are not going to receive more information. And then we start counting once that the workers are gone, are done, sorry. So yeah, this one, I don't know. Jose, do you want to add something else to this code?
No, all good.
Okay, yeah, so these two assignments were pretty useful because it helps us to understand a little bit of Go and the parallelism. So without this, probably we will have a really bad time with the next assignment. So moving on into the second assignment.
I just have a question there.
Tell me.
Yeah, list. It is supposed that is the numbers that you are getting.
What? Sorry, which
list?
one?
List.
List.
Yeah, list is just all the file content.
Yeah, those are the numbers.
Yes.
Yeah, it
Yeah.
will contain all the values of the numbers. Yeah.
Yeah, and how they are stored in the channel. Before it is supposed that you need to store first and then zoom, right?
No, not really. We have all the processes waiting for the channel to be closed. Because
Okay.
we close it after inserting all the values, they are going to wait. When
Okay.
you do this operation, it is a blocked call. It will be blocked until it receives a value, or well, in this case, it will, yeah, until it receives a value that it's for the inserting and for retrieve the information. So yeah, we create first the functions, and then we do this. We do this because with that way, you don't need to have a really big buffer with all the input. And also you don't, they start to work at the same time. All the, call them workers, yeah. All the workers can start at the same time.
Okay.
So, now moving into the assignment 2. In this case, we had to do several stuff. First was to implement the map and the reduce function. This one, it's the interesting thing about this one is that you need to make it generic, right? It needs to be generic because that way you can implement whatever you want as a map or as a reduce. You know what are the inputs and what will be the outputs. And it's pretty easy to implement any solution. So the way that we do it, it's pretty simple. We just get the results here. We read the file, we send it to our map function, and then in this slice we are going to we need to decide to which file we are going to insert this information. The way that we do it is using the module, and that way you can sort of split it in an even way. Almost all the amounts of value should be in each file. Then after that, we know that we have this list. We start writing all the information into the JSON. This was also a challenge for us because the JSON module was not working as we wanted. We tried at the beginning to use the encoder solution that was in the comments. We had some troubles with that. So we found this Marshall operation that will return the, instead of writing into the file, it returns the string of that JSON, and we write it directly. Yeah, so that is the implementation for map. And for reduce, It's something a little bit different. Okay, for the reduce, what you want to do is to classify all the values based on a key. You have a key and you want to have a list of values, right? So we need to classify them using a map. For every value that we find, we add it at the end of a slice. And then, well, sorry, I forgot. You need to encode the output from the map operation. And then after you do that, you just need to call your, okay, you create your merged file. And the only thing that we're doing is for each key, we execute the reduce function with the slice with all the values related to this. And then we save the file. So we close it. So I mean, this one. At this moment, does anyone have any question? Or should I go into the implementation of the map? Okay.
Go ahead, I think. Yeah.
Sorry?
Just later, don't forget to run them, okay?
Yeah. Actually, I try to save some time on that, but I can run it again if you want to. For the first assignment, this is the output. I can execute it again if you want to. And we have for the sequential map reduce 2.3 seconds. I believe that we are not getting the best times because I have in my computer a disk encryptor, and you have overhead to write the file into the file system. So I mean that could impact into that test, right? So well, let me execute. Let me talk about the word counter, and then I can execute the test for word counter. So word count. This one is pretty simple. We just actually this is something that I missed. I know that it was on the comments, but I got creative in the process. I know that there is this fields string fields function that will ignore all the spaces. I did a mistake on this, but well, I am doing a split, getting all the values. This approach has a problem. When we do it in that way, we can have, if you have several spaces, you are going to have some empty values. So I am ignoring those ones and then just append the value. Well, you will end up having a key value object with just saying, okay, I found this one once, and the value it's not important for this. So we just return this slice. And then for the reduce, it's also very easy. You just need to count the length of all the what is the name? The amount of matches that we found, right? So we only have the length and we have to convert it into a string. That's all. Very simple to implement. I have some examples of how the JSON looks. We have here it looks. This one is for the map, right? It's key, Gutenberg, blah, blah, and the value we found it once. And then in the reduce, here, we just have the count. It will look this way, and then the merge function will take care of give it shape, right? But that is the way that the files look during all this operation. So let me show my terminal. Word count. test passed. So that is for the implementation. The main challenge here was to decide how we wanted to have the data structures. You know, if we wanted like a dictionary with as a dictionary or a map, a dictionary or a map, or if we wanted to have it as a slice, or what is the shape that we want for our data. We had some problems with that, and also the other problem that well, the main challenge was to implement the common map. Once that you have this implemented, and I think that that is the most important thing about MapReduce is the implementation. It's pretty easy. You just need to understand which are your inputs and which are your outputs, and this will be MapReduce will take care of all this stuff and take care of failures and some other things, right? So it's really easy for developer to implement, but the tricky thing is that you need to have a really robust MapReduce logic to have it to make it work, right? And I want to, well, Jose, do you want to explain the code related to the distributed solution? Give me a second just to open the files.
Schedule?
Okay.
Thanks. We had some issues here regarding how to use the RPC because, well, we had to look into all the code to see how they were implemented and how to call them. Also, we thought on a way to distribute this from the master to the workers tasks, and we do some research on the channels and the think weight group. At the beginning, we have all the tasks attached to a structure of well, to a we say an array of tasks. Then we have a simple loop to get the next worker available. With the add, we said that there's one worker and we need to wait for just one worker. Then we created a new function called call worker, which will, with the call subroutine, which will do the RPC.
Do you want me to jump into that function?
Sure. Basically here, the only thing it's doing is call the worker with the do task that we had previously. If the task it's okay, then we have an array of failed tasks to know which task has failed. If it's okay, then we say this task is good. We have finished, and we send the message to the register channel, so we know that this worker will be available later. If we fail, then we put the failed task as true. We say that at least one of our tasks has failed, and we also put done because this worker has finished its work, even if it has failed. Could you get?
Sorry, continue.
Up? Could you go up, please?
Yeah. Yes, I just want to add something. For me, this one was like the most problematic thing. We are, well, at least I am familiar with the normal paradigm about programming, and it's not common that you call a function using a string, because it is happening in some other places, and it's a little bit, it's a different paradigm. It's not complex to use, but you need to understand how it works, and that was the tricky one for, well, at least in my point of view. I was here, right?
Yeah. Then we wait for all the processes to finish, all the workers. Then if we have a failed task, we get into another loop and sending all those failed tasks. And basically that's it for the
So
this
as long
this
as we
part of the code. Yeah, as long as we have a failed task, we set that variable false, and then we go all through all the tasks again, and we just check for the one that has failed. We get another worker and send it to do the work again.
Yeah. So
And can you go down just to show how we get the next worker? We read from the channel, from register channel, and we check if that worker is alive from our master workers. If it's not alive, then we shouldn't send that that worker to the message.
Yeah. Do you want to add something?
No, I think that's it.
Well, to decide
Could you run the
Yeah, I can run the test. Just give me a second. I want to add a few things here.
Sure.
How do we decide that the worker is in good shape? Well, this function returns a timeout, right? So it's not only that it was killed for some reason, it could take more time than expected, right? So we can remove it from our queue and go with a worker that it's in better shape. And yep. Well, let me run the test.
Any doubt so far?
Any question right now?
Well, the general issues that we faced were basically learn a new language like the other teams. We weren't familiarized with Go. Learn the concepts of the Go subroutines and synchronization between process for Go. And also, I didn't know about Git and GitHub, so that's something that I think also Oscar from my team learned.
Yeah, that was something new to me. Probably we did we went through the short solution. We have, I'm still, we did downloaded the desktop, GitHub desktop, and this one, as long as it detects a new file or a change, take care of everything. So you only need to press commit. Yeah. Let me execute the test. So this one is the basic one. We can go with the failure one. Let's. This one takes
longer due to failures.
Yeah. So that is the way that it works. And I'm also missing just a quick check into the
I.go. Yeah.
Yeah. So it was very simple. You sanitize your input, and then what we did is that if we found one match, we add it into our list, and we save in which file we found this. And for the reduce, I sorted the values. Why do I do this? It's because in the output that the code the test is expecting, it is in order. So I am sorting it, and because they are in order, I can check which is the previous one that I checked, and if it is a totally new one, then I can add it into a reduced list, and just at the end provide the length of this reduced list and do a join with comma separator. So yeah, basically that is what we did. I don't know if someone have any question about this.
Any questions? All good? He's just tired. Ricardo saying yeah. Okay, thank you. Thank you guys for group 5. Let's go with the last group for today, group 6. We don't have group 7, by the way, okay? And we have group 8 that they were basically joined later, so they have extra time.
Okay. I think that I'm on group 6, so I can, I think.
Yeah, you are group 6.
Yes, you are.
Yeah. I always get confused with the numbers between this and the presentation and the other, how you say, subject. So, okay, I will share. Give me a second. This is interesting. Okay, can you see my screen?
Yes.
Okay, so instead, our team, instead of focusing on the code, we want to try to focus on the takeaways and on into the concepts, because like MapReduce is not like something that you are going to do only on Go and that programming language. That's like something just like in a lot of languages, you know. So we want to focus on the mainly on the concepts and how everything works. So I will, how you say, open like this project. First of all, like, well, yes, the first task, I think that the purpose was to learn Go, mainly like the syntaxes and things like that. The main takeaways from here that I could say are in how you are splitting or creating actually the program. It would be nice, like for example, by splitting it into functions to do certain type of operations, like for example, validations or normalization. So like for example, the first problem that is the Q1, well, the first assignment 1.1, it was about 2 problems, right? The first problem, it was well, it describes that you have a list of words, you want to count them, and you want to get a certain number of words that appear the most of the times, right? So on this approach, we follow, well, we try to use the functions that the professor provided, that it was like, for example, the sort count. I don't know if you can see like the size of the text. Just let me know.
Yes.
Okay, good.
Yes.
So it was provided as the sort counts function. So the same as everybody, like we counted the words, we sort them out, and then at the end, what we did is only get the number of results that we wanted, or if the number of the results was lower than the number of words available, we always return the minimum amount. We discovered that here there are missing test cases actually, because this is not like some test cases that are covered on this implementation, well, on this test execution. But the takeaways that I could say about these first problems, it's that it's by splitting something that it's called normalizing words, that it's like by filtering or converting one type of input to an output and making some operations about that. So that's a super important term, like, well, important thing in programming. Like, for example, on this normalize function, what we did is like only remove all the special characters. And then another important thing when you are programming, it's create a functions only for validation. And how we validate the function, it's like by a threshold, right? So if a word doesn't contain at least those type of characters, then we should like have a function that only you have all the functions that validates that your input is sanitized or it's clean or it's valid, right? So I will not explain the code on this one, because I think that everybody did the same. So I will go to the takeaways from the process two. The process two, it has different takeaways as well. Like for example, first of all, well, yes, the purpose it was like to learn the Go functions, but the Go functions work as a concept called threads, you know, and the purpose of learning this, it was like to simulate multiple processes or threads running at the same time, right? Because this class, it's called distributed systems. So what we want to learn is like how to execute several operations in different machines and synchronize them, and so they can work together, give good results and things like that, right? So the takeaways from this task is like what a channel is and what a worker is. A worker is like a thread, right? It means that you are executing a specific task in something called thread, and it's running in parallel to the other ones. So what we did is like execute a number of threads. That was a requirement. And also then we created something called channels, right? The channels, the important concept about this is the inter-process communication or IPC mechanism. So like channels only exist, well, I don't know if in other programming languages, but at least in Go, there are different inter-process communications like RPC mechanism that, and these processes usually work with a design pattern called producer-consumer, that this is like the important takeaway on this. That it's like there are some applications that are producing stuff and other applications that are consuming information. Yes. On this case, like for example, this application is going to be launched several times. And the way that we communicate with that is by using nums, right? That is the channel. That is our mechanism to communicate. And our producer is our main application where we are putting all the numbers inside. Like for example, you have a queue that is the, how you say, the channel. You are putting numbers, and then all the workers that you have, like several workers, let's say 5, each one it's grabbing all the information in some random order, not necessarily the same one. So that's the important part, that all the things goes into one like a pipe, and then they are distributed. So this is how they relate to the class, like in the distributed systems. So, well, the code is like super similar to everybody's. Like if somebody wants me to go through the code, let me know. But I think that the main takeaways about these things are the concept of a producer-consumer, that and the inter-process communication, that it's our mechanism, so you can communicate one process to other process. So I will execute like these test cases. So if I go to assignment 1.1, right, I can execute good test, and it says that it passed, right? So now, well, if somebody have a question so far? Nope, okay, good. Then I will go to the assignment 1.2. The assignment 1.2, the main purpose of this one, it was to learn how to do the mapping and how to do the reducing, and more or less how it works. That the concept is that, okay, on the mapping, what we are doing, it's only like parsing some type of information, and the reducing function, it's like another function that gathers similar type of information and do some operation with that and gives you another output. I will put some log statements so you can see like all this process, how it works. So at the beginning, in the map reduce function, I will not go, well, let me show first the, what's the name? The map f and reduce f functions. because I think that it's important to explain something about this before I explain how the mapping works. So on the mapping function, like this is also similar code as everybody. What we are doing is reading from files, right? The document represents a file. We read all the words from a file. And what we do is like say like, okay, I count an A. And so I assign I count only one A. So I assign a number 1 here, right? I count a hello. I assign a number 1 and things like that. So the only thing that we are doing is mapping each letter to a 1, right? And in the reduce function, what we are doing, we are getting per each number one element in the there. Like let me show you like by executing this example. I put some log statements to explain how this is working. This is working exactly as the MapReduce presentation that we had like in the class, because it's exactly the same problem, and actually it's solved super similar as in the paper. So let me execute this for everybody. So I think that this is like this, and then we are going to execute it. So something that I want to mention here that as here it says, we're executing a sequential, how you say, process right now. We're not making a distributed process because we're not creating like any threads, like we're not creating any workers for managing all the information. And how the map and reduce functions are communicated, it's by files. So as you can see, like all these files were generated automatically, right? And the important thing is like how they are communicated. So right now on this task, the IPC mechanism are the files. So the mapping reduction, the mapping, what it does, it's write to the files the information, and it represents the information in a JSON format. The JSON format is not like something that it's required. You can write it like in binary or something like that. The important concept here, it's something called serialization, that it's like the way that you consistently transmit the information between two processes. I don't know if I explained myself. Like for example, when you want to communicate from one computer to another computer, they have to understand each other. They have to speak the same language. So you have to have that serialization. Like for example, if I speak with somebody that is from India, let's say, and I speak Spanish and they speak Hindi, we will not understand, right? So right now that that language, it's like JSON, the one that is selected in the task, and we are representing it like this. So as we can see, like for example, project is found 1, importance is find 1, of is find 1, right? So in the log statements that I printed, all this is generated by the map function. Then I put some log statements in the reduce function. So as you can see, like in the, this is, give me a second because this, in the reduce function, I put some log statements, right? So this, it's printed in the console. And as you can see, the log statement, what it's doing is only this thing like wish card, it only appears one time, right? It's assigning the same type of values all together so it can make an operation. So like for example, here, wings, it appears this many times, right? Because of the logic that right now currently we are following, we are assigning a number 1. Actually, it can be whatever. That so in the reducing function, what we can do is only make the addition, or since in this case everything is 1, we can count all the elements, right? So that's like the reducing function. What it's doing is like having a lot of elements and putting it into 1. So that's like the important concept on the reduce function. So if I go here, as I mentioned, like this is a print statement that I did, and we're only counting the values. And then the other important takeaway is that the hashing function. So let me show the hashing function. That hashing function, I think that it's in the mapping. So I think that everybody view this hashing function. I know that probably it could be confused on how to use it, but the important part on the hashing function, it's by a concept called balancing. So probably in distributed systems, you are going to hear a lot about what is called load balancing, right? So load balancing is usually there is also something in mathematics that it's called how you say how you say normal distribution. Normal distribution is that you are giving, let's say, creating numbers randomly, but in a distributed way or in an equitative way, let's say. That, yes. So the thing that important in the hashing, like for example, the hashing actually can be exactly the same number. Like for example, I could return here, return s converted into an int, you know? So a hash, what it means is you operate into an input and you give a specific output, okay? So the important thing about the hashing is that each time that you put an input, it's equally distributed accordingly all numbers, okay? So the takeaway here, it's by creating a hash and then adding the module in the nReduce. That means that when you are generating all the numbers, you are assigning it only into nReduce slots. Okay, that those are like the number of reduce functions that you want to call at that moment. So this is called load balancing, this operation. And I think that this is one of the takeaways about this assignment. As I mentioned, I will not go through the code because it's exactly the same. So in summary, the main takeaways about this is that the inter-process communication mechanism here that are like the files, what the mapping does, that it's like only making some operation and parsing the information in some way. Then the reducing function, that the main purpose of a reducing function is to gather all similar type of information and create another operation over that information. And those are like the main takeaways we think like from this this project. What else? Well, yeah, if you wanted me to execute like the test cases here, I will execute it. Give me a second. I will only comment this because otherwise it's going to take longer. Yeah, you know, like the pipes. So, okay, let me remove this and test WC, right? So that will execute all the test cases from the word count. Yeah, I'm trying to give all the information fast because of matter of time and, you know, it's dark and things like that.
It was nice we finished with you. You provided very nice, like a summary and like conclusions. That was great.
Okay, thank you. So, okay, here it says that the test passed, right? And then like this is for the, how you say? For the assignment 2, right?
Mm-hmm.
And then if we want to go to the assignment 3, gosh, I'm not used to Spanish keyboard. Okay. Assignment 3 here. Like the problem here, well, it's similar and totally different concept problem from number 2. So the thing that is similar is how you implement the mapping, but you are solving a different problem. So here, this is a super important concept that it's called inverted index. The inverted index is like referring to the origin of some operations. Like for example, you have to map some result to the origin of that operation. That's called inverted index. So on like this problem, it's about counting letters, right? How many times do they appear on certain specific files, right? Before, what we were doing is assigning a number 1 to each number, but since this is an inverted index problem, what we want to do is like assigning to each word, where do we find that word, to which file it belongs, or yes. So this is not only for words, this is actually for a lot of different concepts, the concept of inverted index. So that's like one of the most important like definitions that we have like to learn about this project, or about this, what's the name? About this
assignment.
Assignment. Yes. So inverted index is one of the main ones, and the other one is the IPC mechanism, right? As I mentioned, assignment 1, 2, and when you test it, it's a sequential. So it takes longer because we are not creating like any workers, we're not scheduling any task to solve the issue. Actually, when you are creating assignment 1, 3, it requests you to copy the assignment 1, 2, right? So at that moment, we didn't have like the RPC mechanism to communicate between all the tasks that are being executed in parallel. Yes, so the scheduling, let me go to the scheduling. Here, well, the schedule, what it does is to simulate different, how you say, systems working in parallel, right? That's like the only important part. The same as we did in assignment 1.1, that we create Go subroutines. We are creating here Go subroutines to dispatch, to create threads that are going to be working or until they end, right? And how are they going to communicate? Through the RPC, how you say, mechanism. Yes, as I mentioned beforehand, we were using also files that are created because we copy pasted the previous, how you say, the previous project. Actually, you can take them away and it will not make changes. But the important here thing is that all the communication between the mapping and the reducing function, and also about the main system, that how you say, is the RPC mechanism, right? That I think that this RPC actually mechanism communicates in binary format. It doesn't use JSON actually. If you go through the code, you will see that. And as I mentioned before, like for example, well, the mapping function, if you compare it to the previous one, is exactly the same, with the only difference of this. That's the only difference, the document. So instead, the other had this. And this one, what I wanted to know, instead of counting the number, I wanted to know where that number was originated, what that word was originated, right? That's called inverted index, as I mentioned. And then the reduce function, well, I have another, this is like already reduced. This is only to format the output that we want, right? But, and this is only, I say, by sorting the values, because I think that, well, it was in the, what's the name? In the requirements, to sort the values, is to print it in the format. Well, to print it in a specific format. So I will show you like how the files are generated to see that how the inverted index worked. So if I go here and I execute, I don't remember, I think this. Yeah. I have to, give me a second. It's because this thing from, I was moving something from Zoom that didn't allow me to see. So here I have to set the go path. I have to go here. And I can go, well, this is not sequential, probably this is different. Well, it executes. So as you can see here, well, this is like, here, I'm sorry. As you can see from the difference from the assignment 2, here to each word we are assigning the origin of each file, right? And the ending is exactly the same. What we are doing is for each word we will get a lot of values in an array. I will not print them because actually it takes long. And what you are doing is only printing them in a specific format. That's like the only thing that the reducing function is doing. So we had like on the scheduling, we had like some little, how you say, at the beginning we had some issues, let's say, that they were not issues. Like for example, there are important concepts actually. That's like something important here. That it was when creating workers and how to resolve, what's the name? How to resolve failures or resolving failures. That's an important thing. The approach that we wanted to follow, it has like advantages and disadvantages, right? So we decided to go for a for loop, an infinite for loop, and try to create a new worker, to dispatch a new worker. At that moment, if the worker works, we say like, okay, we are done, and we are registering a channel. If it doesn't work, what it will do is continue in the for loop forever. So here, the bad thing is that the program can continue forever if we cannot create workers, right? Another way that we could have done that is when it fails, call the dispatcher. We had this issue like before, but a problem by calling the same type of function when you are making a failure, there is a, how you say, there is a concept called stack, that it's like the amount of memory that you have when you are calling the same type of, well, some functions, you know. And if you are doing this and it fails a lot of times, you will run out of memory and the program will crash. Okay, so the disadvantage of this approach is that you use a lot of memory and also the program can crash. And the disadvantages of the approach that we have is that it will never end. You can set a timer for that, but we didn't want like to make more complicated the program. And that's all. I will only execute like the test cases here if you want.
Yeah, while Paul is running this, I would like to add something that why is this important? This assignment was very important because it introduced us in the step-by-step in order to implement these most complex procedures like the inverted index, which in the end, the inverted index is one of the most popular data structure used in, for example, in search engines like Google. So this is the relevance that this assignment has. Yeah.
And to add to that, like for example, a lot of times you execute the same things like with the two approaches because you can make a lot of operations on that. And also like this type of mechanisms, like for example, the queuing mechanism and producer consumer, it's a super used, how you say, it's a super used, not tool, design approach. Like for example, Amazon Web Services or Google Cloud Platform have something called SQS and SNS messages that are working similar to the channels. And also like, for example, Kafka, that's another tool that it works with the similar concepts. So I think that by this exercise, the more important things to learn, apart from the language, is how all these things are working and what's the responsibility of each function, of the mapping and on the reducing function. So yeah, and as you can see, it's like this passed. And actually, if you saw, it passed like faster than the previous one because this is in parallel and the previous one was sequential. I don't know if somebody has questions because I introduced a lot of concepts.
Yeah, I do have a question. I do have a couple of questions. Can
Yeah.
you go to reduce.go file?
Yeah.
You have there, that's the one on
And the AI, right?
yeah. So you have that dispatch worker. You wrote that function, right?
Which one?
Is the schedule.go?
And the schedule. Yes, the dispatch worker. Yes, actually, like for example, on my team, what we did is everybody solved the questions, and we have different functions. And like for example, we decided to go to the dispatch function because we have a different approach that uses different ones. But yes, this one was written by us. Like for example, let me show you another. So
I'm sorry that I mean that was a question, but that was not my question.
Okay.
The main question. So if you can go back to the schedule. So given or with that said, that you wrote the dispatch. What was it? Dispatch worker or dispatch?
Dispatch worker.
So that one, you put that one on a Go routine, right? When
yes.
So you're saying what would be the result if you remove the Go? Are you saying that, for example, an RPC wouldn't be parallelized if you remove the Go routine?
Yeah, if you move the Go routine until what it will do, like for example, that's a good question. So the Go routine, what it will do when it calls this function, this function it will not be executed at that moment. It will not be. It will be queued somewhere in a stack somewhere. Yes, because of this library. What it will happen is like probably like for example this program could have ended if this line didn't exist. This line could have ended before the dispatcher worker function could be called. It's only put somewhere. So what we are doing is saying like, okay, we are scheduling, that's the word, scheduling, right? Or planning to execute this function at some time when the processor is free. Okay, so what we are doing is like launching a number of tasks. And this function, what it says is like, okay, wait until all the workers are done. Okay, yeah. So what will happen is that all these functions are going to be executed in parallel. So this function, I'm going to execute a number of functions at the same moment, and each one is going to try to start a job at the same time. Yeah, so it can be running for a while, and suddenly the processor stops, and suddenly another function is running, and then the processor stops, another function is running, and so on. Okay.
So that call function, that
this
one, yeah, that one is block. So it's not. It's supposed to
the call function
process to another computer, right? So it would be parallelized.
Exactly. Right. So the call function, what it's going to do is to create a client. I'm sorry?
You're double parallelizing, like you're using threads to dispatch asynchronous, not synchronous, maybe they are synchronous, but that it's supposed to do something extra in another computer, right?
Exactly. So the call function, what it will do is to create a client to start a new task that is the worker do task. So what we are doing is only creating some specific task so we can create the what's the name? The RPC clients, because the RPC clients creation takes time. Does it make sense? So we are creating tasks to create other type of tasks. But yes, like the call function, it will create a client that it will, it's like creating a new job, you know, or a new process. I don't know if this like answers your question.
Yeah, I mean, kind of, yeah. And I forgot about the other question, so can you maybe you can answer other questions while I remember.
Yeah, like somebody else has more questions. Yeah, there are like a lot of concepts that I wanted to talk about, but because of matter of time. Okay.
Oh, that was good. Yeah, you summarized it very well, and you had even like you started like a brief introduction on our next class, which is about distributed hash tables. So that was nice. So that's what exactly we're going to talk next class.
Okay.
So anyone has any questions? More questions? Okay.
No questions.
Okay, thank you guys. Thank you so much. And I knew it's gonna take more time than expected, but not this much, but it's fine. It was pretty interesting. Just when you fill up the file that you have it, please include these subjects so I can filter them, I can group them, okay? Otherwise, it get missed somewhere in my email.
We can send it by email, right?
Yes, send any email. Yeah, doesn't matter really. Yeah.
Okay, Maddie, what about us? We are on day off on the next Wednesday, right?
Yes.
So when are we going to present in 2 Wednesdays or?
No, not that Wednesday, but let me see. I'll set up a time with you to see when you're available. Maybe I don't know, Tuesday or like Thursday. Not Tuesday, no, because that's Wednesday is your deadline. Thursday or maybe even next week, like before the next week, before the class, like coming earlier or going later. But I'll email you. Okay. Okay, guys, just please, I mean, make sure you include this because I'm going to filter this. I mean, all the emails coming from this subject.
What is the deadline so I can handle my time?
Just to send it now because I mean, you cannot wait and like do it later. Yeah, just please fill up now, like just take like 2-3 minutes, fill up now and just email me this with this subject. Put your group number. If you're group 4, put group 4 and so on. Clear?
Okay.
Okay, perfect, guys. Thank you so much for your patience. And yeah, we're done. See you next week. Have a nice.
Good question. This file related with the evaluation from all the teams, I will send you to your mail or where?
My mail. My email, my official email.
Okay.
I put it there. If you don't know, I put it in the announcement.
I have a question.
Go ahead.
In the second part of the other group evaluation, we are going to evaluate ourselves?
Yeah.
Okay.
If you think you were the best presenting team, you say our group was best.
Okay.
Yeah. Again, that's for my reference. Okay.
Okay.
Okay, guys.
How long do we have to deliver this?
Just like next few minutes, because I mean, because you're not gonna remember like what happened like tomorrow. Even you're not gonna remember what happened like next 5 minutes. So
yeah, I have filled the second page, but not the first page.
yeah, the first thing is just creating like the like.
Okay.
Like that.
Mari, one question.
About the first page, I think I forgot to mention. No. I put it already in the text. So everything is there. Go ahead. Another question?
Yeah, for the team A, do we still need to fill the first part because we are still
No.
working?
For you, like no, you send me like that one next week. If you want, you can send me the second page.
Okay.
But now the first page after you finish. We are done. Have a good night. And rest well. See you next week.
See you, buddy. Thanks.
See you guys.
Thank you.
See you guys.
Goodbye.
Thank you.
Thanks. Bye.
Thank you.